Okay, we're going to look at skew. Skew. Okay, skew is just about the shape of a distribution, and there are three different shapes we need to look at. The first one, if we just imagine this is a scale, I don't know, going from something like 0 to 100, it could be the marks you got in your maths test. All right, so these could be marks going along here. And you can see that we could have frequencies up here, or we could have frequency densities if it was a histogram. And you can see that most people kind of got a kind of averagey mark. Most people got 50-ish, and a few people did really badly, and a few people did really well. And if a distribution is skewed, we have a little look at this one. It means that most people didn't do very well, did they? They're in this kind of little section here. Or if we have a look at this distribution, it means that most people did really well. So it must have been a pretty easy test. So we're going to have a look at those in a bit more detail on the next slide. First of all, let's see if we can actually describe the skew. So this graph in the middle is very simple. It has no skew, and the reason being it's perfectly beautifully symmetrical. Nothing's been pulled on that one. And we're going to have a look at this graph on the left. And what I want you to do to work out what we call this skew is we're going to put a ski jumper on the left. It's really important you start him on the left. Okay, ready? So here comes the ski jumper. Whee! Right, that ski jumper is having a positive experience. Okay, so therefore we describe this shape as positive skew. He's having a good time, isn't he, that ski jumper? Okay, let's have a look at this guy. All right, he starts on the left. Ready? Not good, eh? Is he having a positive experience or a negative experience? Okay, you can work that one out. He's having a negative time, isn't he? So that is called a negative skew. The other way that you can always remember it is, can you see the tail here is towards the positive end of the graph, and the tail here is towards the negative end of the graph. So the tail tells you the skew. Positive tail on the right, negative skew on the left. Okay, there are two ways in the exam they're going to ask you to describe the skew. One's using the mode and the median and the mean. So you're going to have to get used to these diagrams. You're going to have to know them off by heart. So in this one, if we take the one that has no skew, the mode is the highest point on the graph, so that's the highest, and that is equal to the median and the mean. So if you notice that the mode is equal to the median, which is equal to the mean, then you have got no skew. Okay, let's have a look at this one here on the left. So the first one that I'm going to put in is the mode, and I'm going to put the mode in at the highest place. So the mode goes here. Now, the second one that I'm going to put in on the graph, you hear that thunder, is perfectly timed, is the mean. And the way that I want you to think of the mean going in next is I want you to think of a mean dog. All right, so there he is, mean dog. And the mean dog has a horrible mean flapping tail. So the mean goes in at the tail of the graph. All right, mode first, mean, horrible flapping tail, mean dog goes in at the tail. And then the third one, and this seems pretty obvious to me, is that medians go in the middle. So the median goes in the middle. So if this was a scale along here, this was a scale, and these were marks from 0 to 100, if your mode is a smaller number than your median, and your median is a smaller number than your mean, then you have a positive skew. So if your mode is smaller than your median, and that median is smaller than your mean, then you have a positive skew. Okay, let's do this one. So the first one that goes in is the highest one, which is the mode. The second one that goes in, is this mean dog with his mean tail wagging. So the mean goes in at the tail, and then the third one is the median that goes in the middle of them. So if you have a situation where your mean is smaller than your median, which is then smaller than your mode, then you have a negative skew. Okay, in an actual exam, they would give you some figures. So let's just say they gave you the mean was 3.2 and they gave you the median was 3.5, and they'll ask you to actually evaluate the skew. So you'd have to know your diagram off by heart, all right? So you'd draw your little sketch, you'd put your mode in first, then your mean dog, then your median, and then you'd just have a look at which one it was. So I reckon it's this one, isn't it? The mean is less than the median. Yep. So you would write that in the exam, all right? Mean is less than the median is less than the mode. You'd write all three, even though they haven't given you the mode. Mean is less than the median is less than the mode. Therefore, it is a negative skew. All right? It would be 1 mark for this bit and 1 mark for this bit. The second way that we might be asked to look at skew is using box plots. So this one here, do you remember this one here had no skew? So the box plot means is everything's symmetrical, and the box plot would look like this. So in the box plot, this would be the lower quartile, this would be the median, and this would be the upper quartile. And we'd have some arms, but I'm not really interested in the arms. And therefore, if you notice that this distance is the same as this distance, so in fact, this distance here is Q3 minus Q2, and if you notice that that's the same as this distance, which is Q2 minus Q1, then you have got no skew. All right, that doesn't obviously happen that often. Yeah, you're more likely to get one of the other two. So this one here is positive skew. And what would the box plot look like? So if we have a look at the box plot, can you see that most of the data is packed up here on the left? So therefore, the median is over here towards the left of the graph. Okay, there's my lower quartile, there's my upper quartile. Okay, so how do we write it? Q3 minus Q2, that's this distance here, is no, it's not smaller, is it? I always go wrong on these, is larger than this distance here, which is Q2 minus Q1. And if you have that happening, then that describes positive skew. Okay, let's have a look at this last one. Let's just move my dog out the way. So on the last one, notice that most of the data is here. It's packed up here on the right, isn't it? So the box plot would look like this, with the median a little bit more over to the right. So if you notice him over that way, then we're going to do exactly the same thing. So Q3 minus Q2, this little distance here, is smaller than this distance here, which is Q2 minus Q1. And if we have that, then we can describe this one as negative skew. Now, the other thing to bear in mind is that from the box plots, so I haven't put my arms in, let's put some arms in. From the box plots, you can also see, this is quite a nice trick, if the box plot looks like this and they ask you to describe the skew, Ronnie uses this, she draws a whale and she gives him a face, there he is, and she says the whale's tail is where the skew is. So the tail of this whale is a positive skew. And you can see if you did the box plot, can't say, I'm saying blocks plot. If you did the box plot for this one and you draw the whale in, you can see there's the whale's face and the tail, the whale of the tail. No, the tail of the whale is on the negative side. All right, so that describes negative skew. Okay, the questions on skew aren't difficult. It's actually just trying to remember how to draw the diagrams. So here's a question. We found the quartiles. What's the skew? So let's start off by doing Q2 take away Q1. So 3.5 take away 1.2 gives us 2.3. And then let's do Q3 take away Q2, which is 4.3 take away 3.5, which is 0.8. And then, of course, we've got to remember our diagrams. So you see if you can remember your diagram. I think as Q3 minus Q2 is smaller than Q2 minus Q1, it is a negative skew. And you would have to have the word skew, and you would have to have this, all right? 1 mark for skew, well, negative skew, and 1 mark for that. Okay.